Assalamualaikum everyone, we are Group 6 and today we will present our project on structure analysis, focusing on the Truss Tower project. This project is part of coursework at UTHM where we apply engineering concept to practical design and analysis. Our group consists of 5 members. Aisyah Humaira binti Muhammad Alawi, which is me, Nur Aini Najwa binti Yusof, Fatin Amira binti Hafizul, Nurin Kristina binti Saidero, and Nur Fatin Ilianis binti Mat Harnizan. Together, we work on designing, analyzing, and constructing the Truss Tower, while also sharing tasks like software modeling, documentation, and presentation. This project aims to connect theory with practice in structural engineering. We designed and built a lightweight truss tower using statistics with software like StatPro helping us model and analyze the force before actual construction. Our truss tower using a triangular configuration to distribute load efficiently while minimizing material use. The specifications were 800 mm high, 300 by 300 mm base, 60 mm clearance from support to horizontal members, and a statically indeterminate structure. We faced challenges such as working within strict material limit, meeting prices and dimension, and ensuring the tower could support high load at minimum height. Our objective was to create an innovative design that meets all the specifications, use StatPro to analyze structure forces, maximize load capacity while minimizing weight, and develop skill in teamwork, reporting, and presenting.
Next, for the methodology part, our project was divided into 3 main stages, which is planning, construction, and testing. During the planning phase, we searched for design ideas and drew a 3D sketch of our truss tower. We also performed a pre-analysis to estimate internal forces and choose the best structure. For construction, we used satay skewers, glue, and thread as our main materials. Before building, we inspected the satay stick to ensure their quality, then carefully measure, cut, and join them using glue and thread for better stability. For the simulation part, we use StatPro software. This tool helps us analyze how forces will act on each member of the tower and allow us to test conditions like wind and seismic loads. It also helps us identify any structural weakness before we move on to physical testing. And finally, we tested the actual tower using load of up to 10 kg to see if it matched our simulation result. For the literature review, our focus was on understanding why truss structures are commonly used in engineering. Trusses are efficient because they use triangular configuration to distribute loads evenly. This makes them lightweight but still strong enough for structure like bridge, tower, and roof. According to Lead and others 2020, the strength to weight ratio of truss is one of the main reasons they are so widely used. We also refer to Bentley System 2023, which highlight how software like StatPro allows engineering to model and analyze complex structure under different conditions such as wind, weight, and seismic load before they build them. This help to identify weak points and improve the design early in the process. Finally, other students show that combining hands-on construction with software analysis helps students understand structural behavior better. It is also improve creativity, teamwork, and problem solving, which are essential skills for future engineers like us.
My name is Nurin Kristina and I will present about the costing of our project. The total cost to complete this project is RM27.12. This includes all the essential materials required for construction as shown in the table. We used 3 packets of satay skewers priced at RM2.90 each, which total at RM8.70. Then 2 glue sticks were used, costing 21 cents per stick, bringing the total to 42 cents. We also needed 7 tubes of super glue at RM2.10 each. That gave us a total of RM14.70. Lastly, 6 rolls of thread were used, but since the price is already given as a bulk cost of RM3.30, no further calculation was needed. When we add all of this together, the total cost comes to exactly RM27.12. This budget-friendly costing ensures we stay within our limits while still using effective materials for our structure.
My name is Nur Fatih Ilyanis. I will be present about manual instruction. This manual serves as a guide to assist users in using StepPro for calculating the force acting on each member of a tower structure. StepPro is a powerful structural analysis and design software that enables energies to model complex structure and determine internal force such as axial force, shear force, and bending moment with precision. The primary focus of this manual is to provide a clear step-by-step procedure for modeling tower structure, applying different types of load, and extracting structural results for analysis. To begin this project, we launched StepPro and create a new project. We enter a suitable project name, selected the file location, and choose the metric unit system. We then set the analyze type to 3D frame, which is ideal for modeling tower structure. Once all information was entered, we click Finish to proceed to the modeling interface. After setting up the project, the next step was to define the geometry of the tower. Using the Geometry tab, we inserted nodes and connected them using the 8-bin tool to form the structural framework. This allows us to replicate the internal shape and layout of the tower accurately. Following this, we assign materials and section properties to structural members. In the property section, we selected the material type such as steel or concrete, depending on the design. We also define the cross-sectional shape like angle section or pipes. These definitions are essential to ensure that the structure behaves realistic under loading conditions. In this stage, we apply appropriate support conditions at the base of the tower. These include fixed, pin, or roller support, which were assigned using the Support tab. Support placement is important for simulating real boundary conditions and ensuring accurate structural response. Next, we define several types of load such as dead load, live load, wind load, and seismic load in the loads and definition section. These loads were applied to specific member or nodes using the global coordinate direction to represent realistic environmental forces. After completing the modeling, we run the analysis by clicking on the Analysis and Design tab. The software checks the entire model and displays any error or warnings. If any issue error, we corrected them before rerunning the analysis to ensure a valid and reliable result. Once the analysis was successfully complete, we enter the post-processing mode to review the structural result. We observe key forces such as axial load, shear force, and bending moment acting on each member. StepPro provides both graphical and tabular displays, which help us to interpret the result clearly. Finally, we generated a complete analysis report. This includes information on geometry, material properties, support conditions, load case, and the result of the structural analysis. The report was exported in PDF format for documentation and further reference. This step ensures that all project data is properly recorded and can be used for evaluation or future improvement.
So the next part is result. The stability and determinacy of the truss, which is member is 46, reaction is 3, and joint is 24. Since M plus R more than 2J, so the truss is statically indeterminate with 2 degrees of indeterminacy, and C M more 2J minus 3 and R more than 3, so the truss is external and internal statically indeterminate.
In this project, we used StepPro to analyze internal force and found that the tower was statically indeterminate with 2 degrees of indeterminacy, making it more stable under load. We faced material limitation using only statistic and glue. but reinforcing the joint will improve the tower stability. This project also helped us develop key skills like teamwork, technical communication, and planning. Overall, it was a great experience in applying theory to real engineering practice.
So in this section, I would like to highlight the overall structure performance of tower as analyzed using STEPRO. The analysis provides a clear and readable understanding of how the tower behaves under different load conditions. By applying accurate load and defining appropriate boundary conditions, the model was able to simulate the real-world behavior effectively. So the results show that the tower remains stable and safe with minimal displacement and internal force all within the material's capacity. This confirms that the structure is well designed to handle typical load. So the study also demonstrates the importance of using advanced tools like STEPRO, not only to speed up the design process but also to ensure compliance with structure code and safety standards. So in summary, STEPRO proved to be a powerful tool for modeling, analyzing and optimizing complex structure like our tower. Thank you.
Based on this project, we recommend improving the material selection, especially the stick used for tower construction. Higher quality and stronger material will enhance the structure's overall performance. In future, projects using thicker or denser stick can help the tower support greater loads and reduce the risk of collapse. We also suggest improving the joint technique between sticks to increase the tower stability during load testing. Additionally, applying incremental load instead of a single heavy load will help us better observe how and when the structure fails, giving us more accurate data for analysis. This project is highly beneficial for engineering students as it introduces key structural concepts such as load distribution, material strength, and stability. It also strengthens our problem-solving teamwork and practical skill essential for future engineering practice.